In a previous video, I explained the basics of differentiation and how to carry it out. I also explained different ways to identify a question that is asking to differentiate. Here you have the general rule. You have to times the power by the x and take away 1 from the power. If we want to differentiate this function, 5 times x cubed, we will have to times 3 by 5, 15, times x to the power of 3 minus 1, which is 2. Now I will continue providing different examples. In this first one, we need to find the derivative of this function. To do it, first, I need to apply one of the law of indices to this term. I need to apply this one. To be able to understand it better, I'm going to write down an example. So if we have x to the power of minus 5, this equals 1 over x to the power of the same index but positive. So in this example, we need to rewrite the function, and I will write this term as 3x to the power of minus 1, because the power of x is 1, so the same but negative, plus 4. And now I can differentiate the function, so f dash x equals 5 times 2, 10, x to the power of 5 minus 1, 4, plus 3 times minus 1, which is minus 3, which means that it's not going to be plus, it's going to be minus 3x to the power of minus 1 is minus 2, plus 0, because this is a constant. If we differentiate a constant, the result is 0. So this is the answer. We can now again use this law of indices, and we can rewrite this as minus, and this term will be 3 over x squared, the same index but positive. Now I'm going to continue with the next one. We have to differentiate this function. First, I need to convert this term using this law of indices. To understand it better, I'm going to write an example. X to the power of 3 halves equals the square root, and it's a square because the denominator is 2, x to the power of 3 because the numerator is 3, and that's the index. So now we can convert this function into x to the power of 3, because that's the power, halves because it's a square root, minus 4x squared plus 9x. And now I'm going to differentiate this, so dy dx equals 3 over 2 x to the power of 3 halves minus 1. 1 is 2 over 2, and this is 1 half. So this is going to be x to the power of 1 half minus 2 times 4, which is 8x to the power of 2 minus 1, which is 1, plus 9 times 1 x to the power of 1 minus 1, which is 0. X to the power of 0 is 1. So this term will be 9. And now I can apply again this law of indices to this term, and this will be 3 halves times the square root of x. square root because 2 is the denominator, and x to the power of 1 because that's the numerator, minus 8x plus 9. These two examples are going to be similar. We have to calculate the differentiation in the same way, but we need to calculate the value at a specific point. For example, in this first one, we need to find the rate of change of the function 5x to the power of minus 3 at x equals 3. The derivative of the function f dash of x equals minus 3 times 5 minus 15x to the power of minus 3 minus 1, which is minus 4. When x is 3, the derivative function of 3 equals minus 15 times 3 to the power of minus 4. And this is, if I apply this law of indices, this equal minus 15 over 3 to the power of 4. This is minus 5, 3 to the power of 3, which is minus 5 over 27. Find the gradient of the tangent to the curve with equation y equals 6x to the power of 2 over 3, when x equals 8. If I differentiate this function, dy over dx equal 2 over 3 times 6x to the power of 2/3 minus 1. This is minus 1/3. So x to the power of minus 1/3. And this is 12 over 3 x to the power of minus 1/3. And this is 4x to the power of minus 1 over 3. I can use this law of indices, and this is 4 over x to the power of 1/3. And now I can apply this law of indices, and this is 4 over the cubic root of x. When x is 8, 4 divided the cubic root of 8, and this is 4 over 2, which is 2. This is an example of a problem of differentiation related to the structural analysis of a beam. I'm going to draw a sketch of the question at the same time I'm reading it. A beam is fixed at one end and subjected to a point load of 1000 newtons at a distance of 2 meters from the fixed end. The equation describing the deflection of the beam as a function of its distance from the fixed end is given by this equation. Find the slope of the beam at the point where the load is applied, x 2 meters. The slope is the tangent line at the point where the load is applied. And this is what we are going to calculate using differentiation. I need to differentiate this equation. So dy dx equal 2 times 100 over 2 x to the power of 2 minus 1, which is 1, minus 3 times 50x to the power of 3 minus 1, which is 2. And this is 100x minus 150x squared. When x is 2. 100 times 2 minus 150 times 2 squared. This equals 200 minus 150 times 4. This is 200 minus 600. And this is minus 400. So the slope at this point is minus 400. It is negative because the beam is bending downward at the point due to the applied load.